Hey everyone! In this video, we're going to look at the volume of shapes. So we're going to start with prisms and cylinders in this lesson. So we have a rectangular right prism, otherwise known as a box, that has a length of 8 inches, a width of 4 inches, and a height of 5 inches. We first want to find the area, which is what we did in our previous lesson. So we're looking for this here. So we know the area of a rectangle is base times height or length times width. So whichever you prefer, we can write that out. So in this case, we have 8 inches is the length times 4 inches is my width. Now when I multiply that, we have 8 times 4 is 32. But keep in mind the units. You're doing inches times inches, so anything times itself can be referred to as that squared. So we're going to have inches squared or squared inches. But remember, area is always in a unit squared because of that multiplication. Perimeter is in that singular because you're just adding up like terms. Area is always units squared. What is the volume of this box? Use an appropriate unit. How can you answer part A, determining the volume? So, some of you already know that volume is equal to length times width times height. So we've already found the length times the width, right? That's what the area is. So the volume is equal to 32 inches squared multiplied by the height of 5 inches. So now 32 times 5, we end up with 160. Now keep in mind, we have inches squared times inches, so that's going to be inches cubed. So basically volume, since it's 3 things multiplied together, it's the area, which was 2 things, with that height, that third component. We're going 3-dimensional. Your units should always be to the 3rd power. So no matter what, your units should always be cubed when you're trying to find the volume of something. So let's develop a formula here. Now, with this right prism, you could just do length times width times height. Reference sheets that you would see along the way would have the volume equal to capital B times H. Now, that capital B is very, very, very important. Capital B is the area of the base, and H is the height. Now, H got cut off there. But capital B is different from the lowercase b that we saw in the previous lesson. It's confusing that they use the same letter, but because so many different things in mathematics have a letter as their shorthand, it had to be double. So that capital B always has to be the area of the base. So in exercise 2, we have a prism that has a base that is an equilateral triangle whose sides measure 6 inches each. The height of the prism is 8 inches. So I'm going to fill that in here. What is the volume of the prism to the nearest cubic inch? So this is a prism. So our volume is going to equal capital B times H. Now, remember, this capital B is something we have to worry about. So we have to find the area of this base. And it's an equilateral triangle, so we know we have 6 inches all the way around. And the area formula from our previous lesson of a triangle is 1/2 base times height. So we can plug that in, 1/2. 6 is our base, but the problem is we don't have the height right now. So remember, we can calculate that height by making our own right triangle in here. So I'd have 3 inches. We're looking for x. So we're going to use Pythagorean theorem. X squared plus 3 squared equals 6 squared. Now, I wouldn't go into simplifying or even plug that into my calculator just yet. I would just keep this here like this, okay? So if I simplify this now, you don't have to, but if I were to simplify this here, I end up with 3 radical 27, and that's what I'm plugging in here for the base. So when I go to find the volume now, volume is equal to that base area of 3 radical 27 times 8. And I would let my calculator do all the work at this point, okay? So when I do that, we're looking at 3 square root of 27 times 8. And it happened to say round to the nearest cubic inch, I believe. So then we're looking at 125 inches cubed. Notice I saved my rounding to the very end. I plugged everything into the calculator, and that's how I found my volume. Okay, now exercise 3, a cylinder is a solid that follows the same rules as a prism, but it is a constant cross-sectional shape and area. So explain why the volume of a right circular cylinder is volume equals pi r squared times h. Well, if I go back to the formula we've been developing here, volume is equal to capital B times h. B is the area of the base. Pi r squared is the area of a circle. Okay, so we have that in there. So that explanation is that pi r squared h, oops, not h, h is making the cylinder. Pi r squared is the area of a circle. Now, they say given the diameter of the cylinder is 12 centimeters and the height is 5 centimeters, determine its volume. Well, if I plug in here, be careful plugging in for r. They gave us the diameter, which means this whole thing across is 12. So the radius is going to be cut in half. And the height they gave me is 5. Now, when I determine its volume, it didn't say anything about rounding. So because it doesn't say anything about rounding, I'm going to leave it in terms of pi for now. So I'm going to go to my calculator and just do 6 squared times 5. We get 180. So volume is equal to 180 pi centimeters cubed. Because remember, that's 6 squared. It's taking the centimeters squared times another centimeters to get the cubed power. But it didn't say anything about rounding, so that's why I'm leaving it in terms of pi, just because I know as soon as I plug in anything with pi, it's going to go with a long, crazy decimal. Now, one of the remarkable facts about the volume of a solid is given by Cavalieri's principle. It states that two solids have the same volume if their cross-sectional areas are the same at any given height. Basically, if you think about the volume formula, so far with these, we have capital B times H. Capital B is the area of a shape. So if you have the same area and the same height, it's always going to have the same volume. Because when you think about it, it's kind of like the formula for volume itself. So basically, this guy Cavalieri got famous, in the math world at least, by just stating what the volume formula really means. It's the area of the base times the height. So if you have the same area and you have the same height, your volumes have to be the same, which makes sense if you think about it. Like if you take a number like 5 and you multiply it by 4, and then you take 5 and 4 again and multiply them, they're still going to be 20, right? So anytime you have the same area of the base and the same height, you have to have the same volume. So if I saw this exercise here, we have 2 stacks of 23 quarters each are shown below. One stack forms a cylinder, but the other does not form a pretty cylinder. Use Cavalieri's principle to explain why the volumes of these 2 stacked quarters are equal. So don't make this more complicated for yourself. Okay, we're talking about quarters here. Quarters have the same area and 23 stacked will have the same height. Basically, if you have the same area and the same height, you're going to have the same volume, okay, no matter what you do. Right prism has a square base, two faces that are rectangles, and two vertical faces that are non-rectangular parallelograms. From the side view, the non-rectangular parallelogram is shown. Determine the volume of the prism to the nearest cubic inch. So, in this case, now we can easily get the area of this base because parallelograms all have the same rule of base times height. So if I take 7 times 4, well, actually, we don't necessarily have the height just yet. So we're going to have to find that height. Well, we're going to use the 7 to help us, though. We're missing a piece of a right triangle. So we are looking for the opposite, and we have the hypotenuse. So we're going to use sine for a moment. So sine of 58 is equal to x over 7. So right now, the height is equal to 7 times sine of 58. So that's my height. It's going to be that for, so as the side view, I've just calculated the height, right? That's my 7 sine 58. Remember, if I go back here, it has two faces that are rectangles. It has square bases. So if that's the side view, like this is 4 and 7, that means this is 4, 4, 4, and 4 because the bases were squares. So that area of the base actually worked out for us. That's going to be 4 times 4 is 16 inches squared. And here's my height. So I'm taking the 16 times this height. I'm just going to let my calculator do work for me here. And what I mean by that is 16. Now, I know my calculator reset, so I'm making sure I'm in degree mode. If you haven't changed your degrees, then you should be fine. But I have 16 times 7 sine of 58. And we get 95 inches cubed because it's volume. Okay, last one. So we have a chicken coop is in the shape of a prism below. Determine the volume in cubic feet of the coop and show your calculations. Now, in this case, I would break it up. Find the volume of this rectangular prism and then this triangular prism. So I'll pause the video and try that, and then we'll come and regroup in a moment. Nicely saw that the volume is equal to the capital B times H, so the area is the base. The rectangular prism I have in purple, so 10 times 7 times 12 got me 840. The triangular prism was 1/2 base times height times 12 to get 240. Add them up to get a combined 1080. And then for the part B, if we want to get everything out in an hour and we want to know how many minutes that takes, feet per minute, so this feet cubed divided by 60 minutes, 18 feet cubed per minute. Thanks for watching, guys.